last about 5 minutes of class, I just gave you a really brief preview of this. We talked a little bit about this guy's name. The way you say that is not La Hospital or La Hospital or The Hospital or whatever. It's L'Hôpital or L'Hôpital.
Tilapia.
It is not a fish. Close enough. The other thing I mentioned to you guys yesterday, please listen up. This is going to be like the understanding of what we're going to be talking about here. Next couple minutes will likely decide your fate on these. So I think you're going to find this. One of the other things we talked about is I think you're going to find that the actual mechanics of this, to a large degree, you're going to be like, that's it. That's really not that bad. Let me give you a preview. Can you do the derivative of x? What's ddx of x? It's not a trick question. The answer is 1. So some of the mechanics are going to be just that easy, really. Where you will find challenge in this is being extremely rigorous and precise in how you communicate why you're doing what you're doing. That's going to be the challenge. Okay? So let's start off with this. As I mentioned last time, there are indeterminate forms that trigger L'Hôpital's rule. The word indeterminate, I think, is worth talking about for just a second. The word indeterminate does not mean undefined. It doesn't mean no solution or things of that nature. All it really means is this. We don't know what the answer is yet. So, for example, we were just talking about lunch a few minutes ago. If somebody asks me, hey, what are you going to have for lunch today? I might say, that's indeterminate. It'd be a really nerdy, weird way of saying it, but the fact is, I don't really know what lunch is yet. I haven't seen it, and so I don't know. Like if I knew what was on the menu, I might be able to answer your question, but since I have no idea what's even going on down there as far as lunch, I'd have to say it's indeterminate. I'll figure that out later, right? We don't know yet. That make sense? Okay. So the indeterminate forms that we are going to deal with would be these right here. We talked about this yesterday as well, where the limit of the numerator is 0, the limit of the denominator is 0, or correspondingly infinities. And there are, 1, 2, 3, 4, 5 other indeterminate forms, none of which are part of our framework. So we're only going to focus on the indeterminate forms that are highlighted in yellow. Make sense? I think it's also important to think about expressions that might look like those indeterminate forms but are not. Those are some good examples right there. For instance, 1 over 0. You can't divide by 0. That's just undefined. Whatever that is just doesn't exist. But if you take 0 and you divide it into lots of parts, how big is each part? 0. Right? So those sort of kind of look like indeterminate forms, but they are not. We're specifically looking for a 0 limit in the numerator and a 0 limit in the denominator, or again, correspondingly infinities. Okay, so we've talked for a couple minutes about the conditions for L'Hôpital's rule, but the question remains, what is it? So here it is. It's down here below. This is L'Hôpital's rule. If I attempt to calculate a limit as x approaches c of f of x over g of x, and for this one, like I said, this is really notation heavy. So what I'm about to show you is very mediocre to bad notation, so don't take this and run too far with this. But if I calculate the limit of the numerator and I get maybe a 0, I calculate the limit of the denominator and I get a 0, that would trigger L'Hôpital's rule, right? The conditions are met. And then if you look at what's happened here, isn't everything the same except the numerator is now f prime? The denominator is now g prime? So this is the mechanics of L'Hôpital's rule. All it is, as long as the conditions are met, you can differentiate the top and you can differentiate the bottom and then retry the limit. Yeah, like reevaluate the limit as x goes towards c of this new expression. We'll talk about why that works in a second, but it is important to realize down here that we are not talking about the quotient rule here. We're not differentiating the whole expression. We're just differentiating the numerator and the denominator.
I would have definitely messed that one up.
I know. That's why I mentioned it, because plenty of folks are like, oh, that's easy, quotient rule. I'm like, no, stop, not quotient rule. So it's not a quotient rule. It's just derivative of top, derivative of bottom. That's it.
You can add C at all?
No C's, other than the C that's already in there, right?
Perfect.
Yeah. Okay. Let's do this. I want you to make note of this last piece here before I prove this to you. L'Hopital's rule can possibly be used lots of times. Could be used repeatedly on the same limit as long as the conditions continue to be met. And you'll see an example of that today. So it would be at this point where you've got to be asking the question, how does this work? Like, why on earth would I be allowed to just look at a limit and be like, oh my gosh, it's a 0 and a 0. Why don't I just differentiate the top and the bottom and see what happens? Like, how does this work, right? So let me show you a proof. I would put this in the category of like a baby proof. There is a more rigorous version of this, but this is still good. This will hopefully help you make sense of this. Will we what?
Just to kind of like let us see it, or will we see it?
You're asking the wrong question. Let's hold that question until the end. And if I forget to answer it, just remind me. So here we go. Let's say that we were trying to evaluate a limit like this. The limit as x approaches c of f of x over g of x, similar to what we had going on up above. Let's say we are presented with this. This will be a very general proof here. And I'm going to start to show you some of the more rigorous notation here. Okay? And we'll practice this a bit today. If I, try to calculate this limit and I realize, look, the limit of the top equals maybe 0, or it could be infinity. And wow, look at that. The denominator, the limit of that, also heads towards 0. This would be my first big hint. Look, it's L'Hopital's rule. That's the condition for L'Hopital's rule has been met. The limit of the top is 0. The limit of the bottom is 0. I'm going to use L'Hopital's rule. Okay, so I'm going to do some stuff here, and some of this might seem a little improbable, and so let's discuss as we need. So check out this next step. Here's what I could do. Yeah. Anybody have any issues with what I've done? What I've done here is I've subtracted f of c from the numerator, and I have subtracted g of c from the denominator.
How did you break the
Yeah, what lets me do that? Can I argue with my own self, since no one's other than that arguing with me? Let me just give you some numbers here. Let's say I had some random fraction. I don't know. 11/9. And I did this. Would you agree with me? This is pretty similar to what I just did. Didn't I just subtract something from the top and something from the bottom?
Mm-hmm.
Is this the same as that?
No.
So would it be fair to say that in doing this, I have taken my original fraction and I have totally changed the value? So if you look at what I just wrote back over there on the left, you see how somebody could look at me and say, no, I don't think so. Because we're trying to prove something here. You can't just go and completely change the value of the expression and be like, oh, I don't like that anymore. Let's just change it to this. Do you see the problem here? So there's only one way that I can get away with what I just did. Do you know what it is? Good thought, but I'm not going to do that. That's not a bad thought. It's sort of like a completing the square sort of a thing. Yeah, that's not a bad thought. But there's a different, not necessarily unconnected way that I'm thinking of. What's the only way that this would actually be valid? Sorry? How is it that I would be allowed to subtract f of c from the top and g of c from the bottom?
Two different functions.
They are two different functions, but whether I subtract like a 2 from the top and a 7 from the bottom or whatever, I'm still potentially
I got you.
making a big, bad mistake. Yeah.
Do you subtract it from the other side?
There is no other side.
You're right.
Yeah.
Oh, could it be
No, I don't
as
think
if
so.
you subtracted like 11 minus 11 times 2 over 9 minus 9 times 2?
No, that's not what I'm doing, though. I'm just subtracting a single number, f of c, g of c, whatever they are. What's the only way this is valid? Go ahead, Olivia.
If f of c and g of c are c.
There it is. This is only valid if f of c and g of c are both 0. That's the only number that works here. If I subtract 0 from the top and 0 from the bottom, would you agree with me? I have changed the form, but I have not changed the value.
Mm-hmm.
Form looks different, but I haven't changed the value of anything yet. And I will try not to change the value of anything. Make sense? Okay. Another step. And, somebody might ask the question, like, how on earth would I know how to do these steps? I don't know. I'm just showing them to you. I want to make sure that you have a foundation of logic on this instead of just like my teacher showed me this thing and I have no earthly idea why or how it works. I want you to have some sense of how it works. So here is my big fraction bar still. Check this out. Would you guys agree with me that all I've done is I've repeated it? I haven't changed anything. So I'm going to change something now. Now I've changed something. What did I do? I heard a good word. That's where we're going to go with it. We're going to go there with it next, but I'm wondering if you can explain what I actually just did. That's where I'm headed. You're right, and that's exactly where we're going to go. But what did I do? I divided by what? Yeah. I divided the top by x minus c, and I divided the bottom by x minus c. Isn't this like reducing a fraction? Think about that. Like if you have some fraction, like 7/14, when you reduce this, technically, aren't you dividing the top by 7 and dividing the bottom by 7? So we've actually been doing that for a long time. So 7 over 7 over 14 over 7, well, that's just 1 over 2. So all I've done is, I've changed the form of this fraction, but I have not changed the value at all. It's really important that you understand this. Same value, totally different form, right? Any questions so far? So let's go where like 3 or 4 of you immediately went, that's awesome. I'm excited that as soon as you saw that, you're like, oh my gosh, it looks like the derivative, doesn't it? You see it? So here's what I can do. This is where we'll actually almost wrap this up here. I'm going to come over here and I'm going to say this is actually the limit as x heads towards c of the numerator over the limit as x approaches c of the denominator. So this goes back to those old limit properties. As long as the limits exist, the limit of a quotient is equal to the quotient of the two limits. Again, this is something we've done before. And this is where, as you guys mentioned a second ago, hey, this looks a lot like the definition of the derivative. And of course, it's exactly what it is. So I'm wondering, does anybody have...
Just keep looking at T's. Your C's look like T's.
Sorry, I don't cross them at least. That would be super confusing if I crossed my C's. Can anyone simplify the numerator in a very radical way? I mean, like, simplify it down to just like a very small expression? F prime of? It's actually C. Numerator would simplify down to be F prime. I'll try with this one a little harder, Jake. Is that a better C?
Yes, much better.
Okay. And can anybody simplify the denominator in a similar way? G prime of C, yeah. Okay, so then what we can do is recall this. I said this, I think, 4 times, maybe more, all throughout this whole process. Not one time did I change the value of anything. Change the form several times. But not once did I change the value. So, would you agree then, since I didn't change the value of anything, wouldn't it be valid then to say this? Yeah? And not once did I change the value of any of those parts, the whole fraction, anything. And change the value of anything. But I absolutely changed the form, no doubt. But because I never changed the value, I should be able to say the thing that I started with has the same value as the thing that I ended with. So notice what's happened. It's the limit is x approach c of f over g. Now it's f prime of c over g prime of c. Somebody in the other class asked, well, wait, how does that connect with the limit? Couldn't I also say this then? This is really the limit as x approaches c of f prime over g prime. Sorry, that one really does look like a t. There we go. You see it? Okay, so let's go back to Jake's question. He said, well, I'll paraphrase. Basically, are we going to have to do this on a test? Right? Yeah. So it's totally the wrong question. Let me just explain it in this way. And this is where this class, and I keep saying this, and I know you get it, this is where this class might be different than some of your other math classes. I am completely disinterested in having you just regurgitate exactly what I showed you. That's not math. That's regurgitation. That's memorization, right? And some of the things we do like border on that, like, I don't know, like the derivative of an exponential. That's like bordering on that. But I certainly am never going to give you this proof like this and say, all right, I want you to memorize it and write it out for a quiz or a test. So short answer is no. However, should I expect that you would know that this is valid? Yeah. Should I expect you to recognize the definition of the derivative? That will be tested, no doubt. Already has been, right? So there are lots of elements in here that I would say I'd want you to be able to connect them. But am I ever going to have you just like reproduce this thing? It feels like a waste of time. That makes sense? Listen, some of you, if I did assign that, I would be willing to bet that some of you would go deep and say, I would really like to do some exploring and like really, really figure this out. But there would be a lot of you that would just be like, tell me what I need to know, I'll memorize it, and I'll spit it back out for you. Give me my A. That's crap. That is just absolute crap. Has nothing to do with learning. Has nothing to do with math. Seriously. If that's all you can do with math, you don't know math. So for that reason, I'm not going to emphasize that, if that makes sense. I'd rather you be a problem solver and have me throw something at you that's a little bit out of left field and have you be like, wow, that might be L'Hopital's rule, and see if you can get where you need to go. Yeah, like your mind might actually be spurred to growth versus the boring, I memorized this. I don't know what it means, but I memorized it. Anyway. Okay, so there's that. Any other questions? It's going to be easier to do these than sit here and talk about them. Because you didn't know how to differentiate yet? Yeah. Your question is good. That's the answer. All right. So let's take a look at number 1. I'm going to do number 1 with you, and then I'll have you guys do 2 and 3, and we'll finish there. So, guys, I want to draw you back to what I said at the start. And I think you're going to find this the case with number 1. You're going to find that the mechanics of this are not that hard. They really are not. What you're going to find is how do I show that what I'm doing actually is valid and makes sense? You might find that to be challenging. Okay? I want to share this with you. Maybe just an illustrative point. The last 2 years at the AP Reading, I've had the pleasure or displeasure, I could go either way, of grading a free response question that had a L'Hopital's rule component to it. Like one of the little sub-questions had to do with, let's use L'Hopital's rule, right? And it was a 2-point question. This little is like 5C or something like that. It was a 2-point question. And the way it works at the AP Reading is I I got to do some different things, but in this case, it was kind of a boring 2 days because I graded the same question for 2 days straight. So when you grade the same question for like 9 hours a day for 2 days straight, you get really familiar with the question, right? And you get really familiar with all the responses and all the variety of things you might see. And after you've graded, I don't know what it would have been, like 600 or 700 questions over the course of those 2 days, you feel like you've seen it all, right? So a fun fact, 2-point question, right? There was one day last year, the whole day, it was the second day, graded the whole day on this L'Hopital's rule question. And just on this one, like 5C, this one little subpart, if you take all the points that I could award for the entire day on this L'Hopital's rule question, this is me grading like 300 plus sets of questions, right? If you added up all the points that I was able to award just for this L'Hopital's rule question, I didn't keep track of it the first day, but I kept track of it the second day because I was blown away. You want to know how many points I awarded the whole day on this L'Hopital's rule question? 5. The whole day. And it wasn't because I was mean or I was, trying to really get them or something. It was because I was following the agreed upon rubric and the process we all followed. I was being consistent. 5 points out of say 600 or something like that, right? I mean, I'm estimating that part, but yeah, it was a really tiny number of points out of a really large number of points. And you know what it had to do with? It didn't have to do with them getting the right answer. Because of those 300 or so tests that I graded, a large percentage of them had the right answer. Had everything to do with, did I actually present the conditions that have been met for me to actually do this?
Plug in 0.
Just getting, they would get some answer and there would be no support for it whatsoever. And so you'll find the intense part of this is the, how do I show that this even applies? It'll be interesting. I think you'll see at the end here, it's really not that hard. So I don't know if people just blow it off or forget or teachers don't teach it or what it is, but it's precise. It's not that complicated. You just have to do it. So here we go. Can I show you a really bad way? You want to see the bad way or the good way first? I'm going to show you both. What do you want? Which way first? Good way first?
I agree.
Good way first? Okay, I'll show you the good way first. So here would be the appropriate way to do this. Let's say it's one of my tests, or this is number 5C on the AP test or something. How do you know what to do? So in your head, here's what you're doing. You're like, it's a limit. I should try direct substitution, right? So you look at it and you're like, all right, well, the limit is x approaches 0 of x. Oh, that's 0, isn't it? You're still just thinking this, right? You look at the denominator, well, sine of 0. The denominator, 0 as well, isn't it? So here's how you note this. I'm going to draw some arrows. You really don't have to draw the arrows. I like to. Here's how you write it. You write limit as x approaches 0 of the numerator equals 0. And limit as x approaches 0 of the denominator also equals 0. So this is the right way to do this. Or this is a right way to do this. If you don't really like arrows, you don't have to write them. I do, but your choice. Yeah.
So it wouldn't count if you just let limit of x goes 0.
No.
Just of that equals.
So if this is what you wrote, we're good. Totally fine. Oops. Okay, and the next thing that I'm going to write, you also don't have to write either. I usually will write something like L'Hopital
You guys think I know how to spell that.
conditions met. Don't get me started on spelling on the AP test. I wish I could have $1 every time I read about like a point of infliction or a point of infection or something. It's like, come on, spelling. Anyways.
You can't mark them off that.
No, well, can't, won't, don't. We don't. Okay, so this is a really crucial step, right? You're saying, look, the limit of the numerator is 0, the limit of the denominator is 0. That means I can use L'Hopital's rule. This is actually really important. So since that condition, say again?
So we should write it.
You absolutely have to write it. Yep. Actually, this last year was a little tougher than the previous year as far as what they expected. If you didn't write that, it really didn't matter what you wrote next. We just stopped reading. 0. Okay? Okay, so you don't want to think this, you don't want to say this, you want to write it. Get it on your paper. Okay, so since L'Hopital's rule conditions have been met, we can then use it. And this is really the easy part. We're going to go limit as x approaches 0. What's the derivative of the numerator? 1. What's the derivative of the denominator? You're going to have to use what? Product rule, right? Because it's sine of x times x plus 1. So it'd be 1 d2 plus 2 d1. Okay, so now we're going to retry this limit. We just applied L'Hopital's rule. We differentiated the top, differentiated the bottom. We're going to retry the limit. Actually, at this point, I know that I'm done with L'Hopital's rule. How would I know that?
Because the top's not 0.
The top's not 0 or infinity, right? The top is a 1. So I know at this point I am done with L'Hopital's rule. Let's go ahead and figure out what this is going to work out to be. If I apply that limit to the denominator, what do I get? I get a 1. So at this stage, I'm going to write equals 1 over 1, which of course is 1. Way that I finish this now is to say something along these lines. Therefore, the limit as x approaches 0 of sine of x times x plus 1 is also equal to 1. This would be a great full credit 2 out of 2 or whatever it is answer. Yay.
Sine of x times x plus 1.
Say again? I just took this and rewrote it.
Yeah, why do you like
Well, stop and think about this for a second.
rewrite?
Because I told you that this equals 1. What does that have to do with the original question? Like this is completely different from that. So you've got to link it. You've got to tell me, what does all this have to do with my original question? Until you actually link it, it's like you saying, hey, Mr. Anderson, what are you going to have for lunch? I'm like, well, last night for dinner I had. They're like, that's nice, but I asked about today's lunch.
Yeah, or I love yours.
And so I'd have to link it, right, with a therefore whatever for lunch today. Exactly. Okay. Keep asking questions.
So you have to write L'Hopital's condition met.
You know what? Let me highlight in red. I'll highlight in red the stuff that you don't really have to write. And you don't have to write that.
You said you do.
No, I said you don't. And you don't really have to write that either. I mean, 1 over 1 is 1. I mean, whatever. You get that. You don't have to write L'Hopital's rule conditions met. Like, I like to do that because I want to communicate to you, here's what I'm doing.
I'm like 90% sure you told me.
Yeah. Like you. I think it's just a timing.
You said if you
I
don't
think
write that, you
You said
It's,
yeah.
it's,
That's
it's,
not right.
I remember saying that. It's definitely a timing thing. Somebody over here said, you were involved in it too. They said, do you have to write this? I thought you were talking about this.
I thought you were talking about like.
Okay, so let's be hyper clear about this. Anything in red, you do not have to write. Anything that is not in red, you must write.
Can you use that therefore symbol on the API?
Definitely. Definitely. Can I talk a little bit about why it's so important to write the thing that I'm circling in blue?
Yeah.
From a logical standpoint, let's think this over. If you're trying to say again,
It's like the only reason that you can do what you did.
yeah, like if you didn't write this, like if all this stuff was gone, and you just went from here to here, and you said, hey, limit is x approaches 0 of x over blah blah blah, and then you just start evaluating this whole other thing. I mean, somebody could look at this and be like, what are you doing? Like, I asked you to do this, and you just start doing that? That makes no sense. But if you go back and you say, well, you know what? It actually does make sense because I calculated the limits, and I got a 0 for the top and a 0 for the bottom. Therefore, this L'Hopital rule thing allows me to do this.
So it's just like the same reason you have to say a function is continuous if you want to use like IVT.
It's a condition. Yep, exactly right. Exactly right. Go ahead.
So quick question. We couldn't write limit as x goes to 0 of that equals 0 over 0.
So,
Because that's what I would go to.
I want to go there next. But before we go there, anybody else have a question about what I've written? We're going to go there right now, but before I erase all this, I want to make sure that... So, again, I want to make sure it's really clear. This is good. This is real good. What I'm about to show you would be real bad. I'll explain why. We're good? Okay. So if it's highlighted in red, you don't have to write it, but it is okay to. If it's not highlighted in red and you want actual credit for this, you have no choice. Okay. All right. So here we go. Here is the number one sort of thing that you see when you grade people's AP tests. All right, we're doing a limit. How about this? What I'm showing you is red like a bad color?
Green's a bad color.
Yeah, green sucks.
Yeah. Or yellow. Yellow's like hazard zone.
Well, red is also a caution-y kind of color. I don't know if we can really see yellow. I'm going with red. Okay.
Red's like the correction, you know.
Yeah.
That's the first thing I'd want to do is just write 0.
Maybe this will make it clear.
Bad.
Okay. Whatever the color, this is bad. Okay, so this is the hard part about this is not going to seem that bad, but it is bad. So I start off by writing that, and my first thought is, hey, look, it's one of them L'Hopital rule things. It's one of those hospital guys things, you know. So let's do this. I'm going to use L'Hopital's rule. Limit as x approaches 0, 1 over, and it's a product rule. 1 d2 plus 2 d1, and looky there, it's 1 over it's 1 over 1 equals 1. Therefore, the limit as x approaches 0 of x over sine of x times x plus 1 equals 1. So the sad part about this, 2 years ago, this would have earned somebody 1 out of 2 points. Last year, it would have earned them 0 out of 2 points. They kind of upped their expectations a little bit last year. So that's kind of a little known fact. The way they grade something like 6 years ago might not be exactly the same way that they grade it this year. But they will always award and reward good math, right? What they accept on the sliding scale of goodness or badness does vary a little bit. So what on earth is so terrible about this? You know? Jake.
Where you don't write at the limit at the top is 0. When you do and you don't.
Kind of did, right? You can kind of see what I was going for. What do you think, Caleb?
Stand for that the whole limit equals 0, so you're saying like the answer to the entire limit is 0 versus maybe not.
Well, you can kind of see, 0 over 0, though, 0 over 0 is not 0, right? Come on, keep thinking. What is so terrible about this? I mean, can you all see? I got the same number that I got when I did it right. We got right.
You don't prove it's L'Hopital's rule.
Say again?
You don't prove that it's the
You don't
L'Hopital
say
rule.
that the limit of
Well, is this not enough?
That's just saying,
No, it's not.
not enough.
Okay.
So you need to actually say that the limit of the numerator equals 0.
Yep, and I agree. That would be a way to fix it, and we'll fix this in a second. But there's something else in play kind of along the lines of what you're talking about that's even more offensive. Like the thing I'm talking about is like really offensive. Say again, Tim? Oh, that's it. That's it. You know what I've done here? I have absolutely abused the equal sign. Up here I said, hey, this limit equals 0 over 0, this indeterminate, we don't know what it is thing. And then down here I said the exact same thing equals 1. That is the definition of abusing the equal sign, because the equal sign means the thing on the left and the thing on the right have the same value. So this is almost like saying that 0 over 0 is 1. Right? And any mathematician worth his or her salt is going to be offended if you do that to the equal sign. I would say, and don't hear me wrong, I don't think math is a religion. I don't think math is a religion. But if it was,
Biology.
the equal sign, no, don't insult math like that. If it was, the equal sign would be one of the more sacred symbols. It really would be, because the equal sign is the great leveler. It means this thing over here, whatever it looks like, and this thing over here, however different it may look, if they're joined by this little guy, they have the same value. Kind of like when like my kids struggle with this right now, the idea of if I give them a handful of copper pennies, it's the same as if I handed them this dirty green piece of paper with a 1 on it. They don't get that. My son especially, he would much rather have 25 pennies than a $1 bill because it seems like it's more valuable, right? He doesn't get the whole, these things have equivalent value even though they look different. It's the equal sign, right? It's incredibly important. And for us to say in one thought, oh, hey, that limit equals 0 over 0, and we're like, I don't know what that means. But then 10 seconds later, oh, no, that limit equals 1. Somebody's lying, or you don't know what the equal sign means, one of the two. So the way we would fix this is exactly what Ryan suggested. So I'm going to take away the this is bad, and if all I did was change this to the limit as x approaches 0 of x equals 0, and same thing with the denominator, then we go from terrible and offensive and all that stuff to happy and full credits and all that good stuff. Okay.
What if you were to have the limit in there?
What do you mean?
Like if you just did an arrow over and then 0 over 0.
Interesting question. 2 years ago, you would have been good. Last year, no. So that is not rigorous. Like what you're suggesting is not rigorous math. 2 years ago, they were okay with all right, we'll bend the rules a little bit for them. Last year, they were very rigid. They were like, we will not be bending the rules for anyone. Hence the whole 5 points in the whole day thing. So what I'm attempting to show you is rigorously correct math. And if you do it this way, no matter how far they bend or don't bend, you're good. Okay. Why don't you guys try one of these on your own, like number 2. Please remember, you want to remember this for number 2, that it is possible for L'Hopital's rule to be applied more than once to the same question, as long as the conditions continue to be met. So practice writing good conditions. I think you'll be okay. For the numerator, did you guys see limit as x approaches infinity of x squared equals infinity? And then similar idea for the denominator, limit as x approaches infinity of e to the x plus x equals infinity. So this means the L'Hopital's rule conditions have been met. So we try to do it. Trying to execute L'Hopital's rule. Do you guys end up with this? So pretty simple derivatives for you guys to do. The only issue is when you try to evaluate this limit, you get the same kind of thing, don't you?
Yeah.
You get the limit of the top is infinity. Limit of the denominator is also infinity. And maybe you start to think you're going crazy, or maybe you messed up or did something wrong. Truth is, you haven't made any mistakes. It's just we have another indeterminate form that meets the L'Hopital rule conditions, so we just do it again. So thankfully, we only have to do it this one more time. We get 2 over e to the x. Can I show you a little minor thing that might kind of catch some of you? Several folks have done this over between my 2 classes. Be careful with this. This is another little issue with the equal sign. 2 over infinity. It's like infinity is not really a number, right? You might think that, right? In your head, you might be thinking 2 over infinity. What is that? Oh, it's 0, right? I would petition you to just leave that in your head and go there. Numerator's held constant at 2. Denominator is getting large. Overall fraction going towards 0.
So did you get marked off?
Like I said, they are hypersensitive. So I'm going to suggest that you don't do that. Like if you do that and then you write equals 0, just scratch out the 2 over infinity and I won't look at it.
Oh yeah. Would this be worth 1 point at this? Out of 2?
Well, so I haven't quite finished yet. So you need to say this. Therefore, the original limit is 0.
If you did do that last part though, it would be one less part.
The whole 2 over e thing.
Therefore.
Yeah, you want to draw it back to the original question. Oh, that's what you were asking about. If you didn't put that on there. No. Other questions?
Yeah.
Okay, so we're not going to do the final question, but we are going to fix the typo. So if you would, please flip to 3. We'll do 3 and 4 on Wednesday. That'll still leave us plenty of time to review. I was hoping to do 3, but you had good questions, and so we didn't get to it, and that's all right. So check this out. The typo, it's real simple to fix. We're going to leave everything the same, except in the denominator. You see the t in the denominator?
Mm-hmm.
We're going to pretend like the t is like an x that tried to stand up. We're going to erase the t. We're going to replace it with x. Otherwise, it doesn't make any sense. We're just going to pretend like I misspelled x with a t. Anyway, so it needs to be that. Have a great weekend. See you guys next week.